Hello again. We carry on. This is, I think, the fourth video on the use of the qtVlm simulator. But now we have got to the point we've been working up to, in a sense. This is now I want to cover what is essentially the one of the most important aspects of marine navigation. And this type of program, others will do similar things, but this program is set up to do this very well. And that is, we want to monitor and watch the COG predictor compared predictor line compared to the heading line. Absolutely a fundamental part of safe marine navigation. So let's start. Again, there are 2 or 3 earlier videos that talk about the setup. So let's turn on the simulator, and again, I may have to just adjust a few things as we go. I'm going to do Option S to turn it on. Did that work? No. I have to click the get the focus here. Option S. Now the engine's on. I'm going to turn the engine off for the moment, and let me just turn the boat a little bit to the right here. A little bit more. I want to illustrate a point that I don't think I've mentioned in any of the earlier videos. Okay, so and again, we're going to be doing this mostly. Oh, I'm not sailing yet. I've got to turn the engine on. Okay, so I've got the engine on, and in fact, I think I can even stop here to make this point. Yes, I think so. Okay, so I've stopped, but if I want to go sailing, I want to just point out some of the features here. This is a micro board, and this is a dashboard over here. And this arrow shows the direction of the wind. I think let me just go sailing here just a little bit. And you see it shows the wind direction here. You see, and it's red. Now that arrow's red. And so what that means is I'm sailing downwind, but I'm not at a very efficient angle. See, these are the efficiency for this wind speed. This polar diagram is showing me the efficient angles, and that's in the green. So I really need to come up a little bit into that wind to get a little bit better. Okay, so now you see I'm sailing over here at what? Probably just about my most efficient angle to go downwind. Not necessarily to go to where I'm going, but to go downwind. Anyway, that's the point. This arrow always shows up here, and as you're practicing and driving the simulator, especially when you're sailing, then keeping an eye on this or this is a good way to keep track of what's going on. It looks like, and now I get back to things we discussed earlier in earlier videos, I've got the COG predictor line going up here, but it looks like I've got current already turned on. I must have tested that. Let me stop here. I'm going to go to position. This is sheet. I'm going to turn the engine on and stop. Okay. I want to show where you turn the current on, and that's a tidal current that flows across this region. Later, I'm going to come back and have some dedicated discussion of doing the sailing simulation. I've just been, in the last few, bumping on and off, turn it, sail, engine, sail. But we're looking at the functionality, the navigation monitoring tools now for the time being. So you turn on this. Okay, so I come back, I go up here. This windsock, that's the grid configuration tools, and this is under corrections. And here's where the current, and yes, indeed, the current's turned on. Current's turned on, and then this is a simulator, so you set this where you want. It's 150 going in direction 060. So the current, this is always current direction is way the current flows toward. Okay, so that's on. So let's see what's going on here. Okay, the engine's on. But the boat speed is 0. Sails are all down, presumably. And the engine's on. The boat speed is the engine speed is 0. But look over here, COG. And sure enough, it's doing exactly what we'd expect. We're drifting in that current. We've got a current speed of 1.5 knots, and we're drifting in direction 060. So now let's just get some way on here. I'm going to crank up and get some speed. And let me pull this down here. And then let me turn over here. Okay. All right, so let's just, here's the case. So we're driving, this is the direction that we're reading on our compass. This is a digital readout of the heading sensor, 354. So the boat, we're driving 354 in this direction. But we have a current going 1.5 knots. We know it's 060 because we set it up. But let me point out something very important here. This program is not reading what we set in the simulator and putting it here at 1.5 knots. It is actually calculating. It's getting it's reading a simulated heading sensor that where the boat speed is 6.0 on our knot meter. That's our engine throttle, and our heading on the compass this is true, but our heading is 354. Then this current is changing our direction. It's changing our direction. Hang on just a minute. I forgot something. Okay. Our current is changing our direction, so we're not going where we want to go. We're getting pushed over here to this direction. And the speed, we think we're going, our knot meter says we're going 6.0, but the GPS tells us we're actually going 6.8. You see? So we're getting set. And then this line here, now if I'm just setting up, and this looks like the navigation mode I'm going to be running under for some hours, I'm looking at this heading line here, and the heading line's a little bit short. I'd like to have that up here so I can compare these two very carefully. This is the heading line where the boat's pointed. That's the track. This is the way we're actually going. So you could do something like this. You could right-click here and say Ruler Tool, and then come up here and what is that? Is that the ruler tool? Heading. Oh, 0.9 nautical miles. Oh, okay. That's right, 0.9. Okay, so there's a mile, something like that, up in front of the boat. Okay, so I could make the heading line something like a mile. I want these two to be kind of like, I don't want that clear off the screen. I don't want a little stub here. So what you would do then, let's see if I can do that while the simulator's still running. I'm doing Command Option V on a Mac to get this control. Then I'm going to boat. And now here is, what do we want? We wanted about a mile. A nautical mile is 1852 meters. So let's go 1852. That's a mile. So the heading line is now pointing out a mile in front of us. Okay, so that works. That gives me a good idea of this. You see, as I turn, it's going to be different because I have a different interaction with the current. You see, something like that. Well, let me go. You see even more. Okay, so there's something like that. And so that, what am I doing? I'm on the engine. I'm going 6 knots. Now, look, my SOG is almost the same. My SOG is almost the same. Now, again, this is calculating this. It doesn't display. It says you have to, if you push this button once. Well, no, wait a minute. That's a long push. I want a short push. Oh, I'm not. Oh, yeah, okay, just let me do a long. I don't know my long from my shorts. Okay, so here you go. This is generally a short push on one of these dials. We'll put up a dial. I mean, of these LEDs, we'll put up a dial, and a long push will bring up a graph. It'll plot it. But you see, here's the current. It's 1.5 knots in 060. And let's see, where is that? So that's going to be a short push. Okay, to hide that again. So, but again, it's computing that. It's actually computing that. So the difference between this, well, this vector is 6 knots in that direction. This is 5.9 in that direction. Let me turn a little bit more so they're a little more different. Just for the heck of it. Okay, that's good enough. Okay, so you see, I'm going 5, and I'm actually getting set that way. All right, now. Here, let's go to another. So that's how this works. So we know right now, just looking at this picture, I have as plain a day as I could get. I'm looking 6 minutes ahead. If I want to look 7 or 8 or 9 minutes ahead, I can do that. It's going to always scale that properly. But the main thing I learn here is I'm not going where I think I'm going. Now, if I want to really go this direction, you see, what's the current? The current is flowing towards 060. So if I want to, and I'm getting pushed that direction, I'm driving that direction, I'm getting pushed that direction. So I'm going to have to turn left. If I want to go straight, I'm going to have to turn left into the current. But now again, we would call this outsailing. We're just outsailing here. We're not navigating. If I want to navigate, I have to have a route, a waypoint, some routes. So let's just do that for now. Let's create a pathway, and I'm going to, just the way you would www, something like that. And I think all these defaults are okay. And let's just say I'm going from here, and I want to go to here. Okay, escape. Now that's where I want to go. That direction. I want to go. I want to sail in that direction, right? Let's say. Let me just move that up there. You see, that's the direction I want to sail. That's my route. That's my route. Now I don't have any measurements of that route here on the distance or the velocity made good, but I could then activate the route, and now it's activating it to the first point, and so the next thing you would do is advance to the next point. Now you see the boat is trying to get up to this point, and we now have all the data, the distance and the course to get there, the distance to get there, velocity made course, and how far off this track we are, which is 269 meters. If I measure this distance, it'd be 269 meters. Okay, now I've got to just turn into the current. What do I want to do? What is this heading here? This heading is 301 true. 301 true. So what I would do is I've got to turn into the current. You see, I'm going this way. I don't know if that's intuitive or not, but I've got to turn into the current. You see, I've got to turn in. Stop, turn too much. Okay, so you see my heading now is going to be into the current, but then my COG, I'm a little bit overstanding where I want to go in a sense. Or, okay, so you see if I really want to go this, what is this, 301, I've a little bit overstood that heading. So I could come back and maybe turn a little bit to the right, and I can actually get this heading. So I could drive the boat so that I get exactly the heading that takes me to that mark, right? But in practice, in general safe navigation, what you pick this route for a reason. You want to be on that track. So in a sense, your safest bet is really crank around a little bit. I mean, we're under the engine. Once we start going sailing, then... So here's a point. So what you might do is a little bit overcorrect, until the boat gets up on this line. See, once you get your boat back on the safe track over here, which I could do maybe by let me crank up the boat speed a little bit here. Well, anyway, you see the point. I think you see the point. What I want to do is I want to drive back till I get back on my intended track, and then I can fall off or turn right a little bit more and go the direction I want. But I want to get on my intended track. I can fake that a little bit. Let's just say this is up here. Okay, so I'm essentially there now, and then I would turn back to the right and follow the track. So I've defined a safe track through various hazards or whatever up here, and now I'm back navigating. All right, so this program is remarkably well set up to do safe navigation. Not only training, we're doing training here, but when you have these kind of tools in your boat, then that's what you would use. And I should point out that most of the good navigation programs have tools like this. They may not have, Time Zero has a cone like that, but not many. Most only you have to go to Ectus to get that. But anyway, you can do this with this is for anti-grounding danger detection. For just plain safe navigation, you just need the COG Predictor line and your heading line. Okay, I'm going to leave it there. And this will come up. We're going to do some more actual examples, but this is how you set it up, and the principles of safe navigation. Monitor the heading line. We have a case, and I'm going to put links to it. We have a case where we did a simulation or reenactment of the grounding of the Ever Given, the super container ship Ever Given, that ran aground in the Suez Canal. And if you watch that video, you'll see that if there was a careful monitoring of these two lines, that may have been avoided.